Today we're going to be proving that the arc of hyperbolic of cosecant of x is equal to the natural log of 1 over x plus the square root of 1 plus x squared divided by the absolute value of x, with x's range being not equal to 0. For starters, we know the definition of the hyperbolic of cosecant of x to be equal to the reciprocal of the hyperbolic of secant of x to be equal to 2 over e to the x minus e to the negative x, which I'm going to be setting to be equal to the variable of a. Therefore, by definition, we can find the variable of x through the arc of hyperbolic of cosecant of this variable a that defined to 2 over e to the x minus e to the negative x. From here, we can analyze the equation of 2 over e to the x minus e to the negative x is equal to a by starting by letting e to the x be equal to the variable of n. With this in mind, we can substitute it to get 2 over n minus 1 over n is equal to a. Simplify the denominator to get 2 over n squared minus 1 divided by n is equal to a, which is also equal to 2n over n squared minus 1. We can multiply n squared minus 1 both sides to get a parentheses n squared minus 1 is equal to 2n, which is equal to an squared minus a. We can subtract 2n on both sides to get an squared minus 2n minus a is equal to 0. Notice how this an squared minus 2n minus a is written in the form of quadratic equation, which is written in the form of ax squared plus bx plus c is equal to 0. With the quadratic equation comes the quadratic formula, which states we can find the variable of x through negative b plus minus the square root of b squared minus 4ac divided by 2a. With this in mind, we can relate it into our quadratic formula of an squared minus 2n minus a is equal to 0. A common misconception is the question of why is an squared minus 2n minus a written in the form of quadratic equation? The reason for this is because we define a to be equal to 2 over e to the x minus e to the negative x. Whatever input of x, the denominator will factor out and come out to be some constant, whether that be 0 point something something or 1 point something something. I don't care about that. All I care about is that a will be equal to some constant, while n is our variable because we set e to the x be equal to n. We don't know what e to the x is equal to. We just set it to be equal to the variable of n, while we know what the variable of a will be, because a will be 2 over e to the x minus e to the negative x. Therefore, we have a variable and we have the constants in front of it, with the highest power being the square, which is equal to 0 in the form of a quadratic equation. So we can solve this quadratic equation by first defining our a term, b term, and c term respectively, which will be a term being the coefficient of n squared, a, b being the coefficient of n, negative 2, and c being the coefficient of, well, not coefficient, well, c will be the constant, which is negative a. With this in mind, we can substitute into our quadratic formula to find our variable of n to be equal to negative b, which is 2, plus minus the square root of b squared, which is 4, minus 4 times a times negative a, to get 4 plus 4a squared, divided by 2 times a, which will be 2a. This will be equal to 2 plus minus 2 times the square root of 1 plus a squared, divided by 2a, which all I did here was factor out the square root of 4 from the square root of 4 plus 4a squared, which will be then equal to 1 plus minus the square root of 1 plus a squared divided by a by simply dividing 2 in both the numerator and the denominator. This will be equal to the variable of n, which we previously defined to be equal to e to the x. Therefore, we can resubstitute it to get e to the x is equal to this quantity right here. We can find the variable of x's quantity to be equal to by taking the natural log of 1 plus minus the square root of 1 plus a squared divided by a. Remember our previous definition once again, that x is equal to the arc of hyperbolic of cosecant of a. That variable of x is the same x right here, which will be then equal to the arc of hyperbolic of cosecant of a. And now we must argue for whether we take the plus or minus sign and whether we keep the restriction of a. To know this, we must keep in the back of our minds that e to the x will always be greater than 0, whether x having the range of all real numbers. So with this in mind, whether we take the plus or negative sign will be a simple case, because we know that the square root value will always be greater than 1, a being for any number other than 0. And why can't a be 0? The reason why a can't be 0 is because a is present in the denominator, and we know the one number that cannot be in the denominator is 0, such as 3 over 0. This will not make sense. Any number or any fraction with 0 added its denominator will not make sense and will not be defined. Therefore, we know straight off the bat that a is not equal to 0. And now we try for a is not equal to 0. Let us try to get rid of the plus or negative sign. And to do this, we actually need to take apart this fraction to be 1 over a plus minus the square root of 1 plus a squared divided by a. This hasn't changed anything. But let us analyze what would happen if we take the plus or negative sign. And to know what would happen, we must compare the two quantities of 1 and the square root of 1 plus a squared. 1a with a restriction of a not being equal to 0. And what will happen with a? A can be equal to any number and yet will still come out greater than 1. A can be equal to 5, a can be equal to negative 4, a can be equal to pi. Whatever you like, a will always be greater than, or not a, the square root of 1 plus a squared will always be greater than 1. Therefore, if we know that the e to the x will always be greater than 0 and that the quantity inside the natural log cannot be a negative value, we know that the length of 1 over a must take the plus symbol of the plus minus sign. Because if it's minus, remember, 1 is less than the square root of 1 minus a squared. Therefore, if it's negative, what would happen? If it's negative, it would become a negative quantity within the natural log. It would not make this equation true. So with this in mind, we're almost done with this proof, and that is we must take the absolute value of a. And that might seem very arbitrary because I just suddenly pulled that off the bat because from the start we were trying to prove it. Well, why do we have the square root, or not square root? Why do you have the absolute value of a? The reason for this is because if a is a negative number, a small number, which is 1 over a, minus a big number, that is the square root of 1 minus a squared divided by a, will result in another negative quantity. Let's say a is equal to negative 3 without the absolute value symbol. That will be equal to the natural log of 1 over negative 3 minus the square root of 1 minus 9 divided by, or 1 plus 9. This is supposed to be add. Yes, that's supposed to be a addition sign, not a subtraction sign. My apologies. Divided by 3. Well, the square root of 10 over 3 is obviously greater than negative 1 over 3. And what will we get? This will become a negative quantity. Let's say that's negative x. We cannot take the natural log of any negative quantity. Therefore, we cannot have a be a negative quantity under the square root of 1 plus a squared. So we have to take the absolute value of that in order to ensure that our natural log will make sense, along with the restriction of a being not equal to 0. Hence, we have proved this equation of the arc of hyperbolic of cosecant of x is equal to the natural log of 1 over x plus the square root of 1 plus x squared divided by the absolute value of x, with x's range being not equal to 0, and wrapping up and concluding our set of formulas for the arc of hyperbolic trigonometry.